There's a small dark purple fruit sitting in a lot of our kitchens right now that scientists have spent over a decade studying for one very specific reason.
Its possible effect on insulin resistance, one of the biggest health problems in the world right now.
And the numbers are pretty striking. 37% of adult Americans currently have prediabetes.
That's more than 1 in 3 adults walking around with blood sugar that's already higher than normal, years before anyone actually gets a diabetes diagnosis.
So the question is, what if something as simple as a food a lot of people already eat could help catch that process early?
That's exactly what researchers have been trying to figure out with blueberries.
So why blueberries specifically? What makes them interesting to scientists in the first place?
They're rich in polyphenols, plant compounds, and specifically a type called anthocyanins. Anthocyanins are the natural pigments that give blueberries and other dark-colored fruits and vegetables their deep color. They also have antioxidant properties.
I actually didn't know this, but apparently increased blueberry consumption has been used as a folk remedy in Canada for treating type 2 diabetes for years.
Right. And it's not just folk wisdom. Epidemiological studies, the kind that track large populations over time, have reported that people who eat more anthocyanin-rich foods, blueberries in particular, tend to have a lower risk of developing type 2 diabetes faster.
So does the actual clinical evidence back that up?
That's the real question. A review published in the journal Antioxidants pulled together results from both animal and human studies to find out exactly that. And the answer turns out to be more complicated and more interesting than a simple yes or no. Before we get into what the studies actually found, let's back up. What exactly is insulin resistance? Why does it matter so much? Insulin resistance is when your body's tissues become inefficient at taking up and using glucose in response to insulin. It's not diabetes itself. It's what happens in the stage before that, called prediabetes. Blood sugar is higher than normal, but not high enough yet to be classified as type 2 diabetes.
And that's the window where it still matters most, right? Where you can actually do something about it?
Exactly. That's the stage where corrective action can prevent or delay the disease from progressing any further. Which is exactly why researchers wanted to know, can something like blueberries actually make a measurable difference here? Let's get into what they found.
So where did researchers actually start with this? Animals or humans first?
Animals, mostly. A number of animal studies looked at obese rodents, some diet-induced, some genetically manipulated, that were fed a high-fat diet along with blueberries for anywhere from 3 to 12 weeks.
And what did they find?
In several of those studies, both insulin resistance and glucose tolerance improved. Researchers used a few different measurements to check this. Things like HOMA-IR, which estimates insulin resistance, insulin tolerance tests, and glucose tolerance tests.
Can you give me a concrete example?
Sure. One study looked at mice that ate a high-fat diet plus 4% blueberries for 8 weeks. Those mice had a lower plasma glucose response during an insulin tolerance test compared to mice on the high-fat diet alone, meaning better insulin sensitivity. Their results actually looked similar to mice eating a low-fat diet altogether.
That sounds pretty promising. Was it consistent across every animal study?
No, and this is important. It wasn't. Other researchers found no effect of blueberries on insulin resistance or glucose tolerance in obese mice and rats. One study didn't see any change in HOMA-IR with blueberry supplementation, though they did find some other biological changes, lower levels of certain blood markers tied to glucose metabolism, like hemoglobin A1c.
So even at the animal level, it's a mixed picture.
Right, and that mixed pattern actually continues once researchers moved into human studies.
Let's get into that. What did the human research look like?
The evidence in humans is actually described as sparse. One research group was the first to publish a report on blueberries' clinical impact on whole-body insulin sensitivity, specifically in people at risk for type 2 diabetes.
What did they do?
Participants drank a smoothie supplemented with blueberries for 6 weeks. Compared to people who drank a placebo smoothie, the blueberry group had a greater increase in insulin sensitivity. This was measured using what's considered the gold standard method, a hyperinsulinemic euglycemic clamp.
That sounds like solid evidence.
It is, using that specific method. But here's the catch. Other studies, including from that same lab, also used less sensitive methods, like HOMA-IR and a test called FSIVGTT as secondary measurements. And using those less sensitive methods, they found no significant changes in insulin sensitivity between the blueberry and placebo groups.
So the same researchers looking at the same people got different answers depending on which test they used?
Exactly. And that's a pattern that shows up again with blueberry or bilberry extracts, not just whole berries.
One study using a gastrointestinal microbiome modulator containing polyphenols from blueberry pomace found improved glucose tolerance after 4 weeks, but no change in insulin resistance. Another study with people who had type 2 diabetes had them take capsules with 80 milligrams of anthocyanins twice daily for 24 weeks, and that one did show a significant improvement in insulin resistance.
It really does sound like it depends on the study.
It does, and that's exactly the tension this review is trying to untangle. Real signals of benefit, but not a consistent, unified answer yet.
Okay, so if the evidence is mixed, what do researchers think might actually explain why blueberries help in some studies and not others?
One factor they looked at is body weight and obesity. It's already known that obesity is a major contributor to insulin resistance, so some researchers wondered if blueberries' effect might just be tied to weight loss.
And was that the case?
Not consistently. Some studies did find that obese rodents eating blueberries had reduced body weight gain or fat accumulation alongside improved insulin sensitivity. But other studies found the opposite. One actually saw increased body weight and fat with blueberry consumption. And in that case, blueberries didn't improve insulin sensitivity either.
So weight loss isn't the full explanation.
No, and it gets more complicated. Other studies found blueberries improved insulin sensitivity in rodents even when body weight didn't change at all. Same story in the human studies. Blueberry intake over 6 to 8 weeks didn't change body composition in participants, yet insulin sensitivity still improved in at least one of those trials.
So it's not simply blueberries make you lose weight and that's why insulin sensitivity improves.
Right, it looks like something else is going on biologically.
So what are the actual mechanisms researchers are looking at?
A few different ones. The first is inflammation. Chronic inflammation is thought to be a link between obesity and insulin resistance. Fat tissue accumulates immune cells that release inflammatory compounds. Some animal studies found blueberries had an anti-inflammatory effect, lowering certain inflammatory markers in fat tissue and blood.
Did that hold up in humans too?
Less clearly. When whole blueberries were used as the intervention in human studies, the effects on inflammation were less pronounced. Several studies found no difference in inflammatory markers between the blueberry group and the placebo group over 6 to 8 weeks, even in cases where insulin sensitivity still improved in at least one of those trials.
So inflammation might be part of the story in animals, but it's not fully explaining what happens in people.
Exactly. The second area is how glucose actually gets taken up into cells. There are 2 possible pathways, one that depends on insulin and one that doesn't. Some studies found blueberry compounds increased glucose uptake through the insulin-dependent pathway. Others found the opposite, that the effect happened through an insulin-independent pathway involving a protein called AMPK.
So even the how isn't settled yet?
Not yet. One study found blueberry compounds didn't increase glucose uptake in muscle cells at all, but did reduce glucose production in liver cells. So there may genuinely be more than one mechanism at play, depending on the tissue involved.
Anything else researchers are looking at?
A few other angles. One is a hormone called GLP-1, which stimulates insulin secretion. Some anthocyanins were shown to increase its secretion in cell studies. Another is a receptor called PPAR, which plays a role in obesity-related metabolic disease, and blueberries were shown to increase its activity in a few studies. There's also research into how anthocyanins may protect pancreatic beta cells from damage caused by high glucose and fat levels, and into their ability to boost the body's own antioxidant defenses.
That's a lot of different angles pointing in a similar direction, even if none of them are conclusive on their own.
That's a fair way to put it. And it's worth mentioning, the review also points out some real limitations in how these studies were designed. Placebo drinks weren't always well matched to the treatment in terms of fiber content, which matters because fiber itself affects glucose control. There were also questions about whether components in the placebo, like added dark dye, might have influenced results, since the dye's chemical structure was related to anthocyanins. So even the comparison groups in these studies weren't perfectly clean. Right, and that's part of why the researchers are cautious about drawing firm conclusions from what exists so far.
So after going through all of this, the animal studies, the human trials, the possible mechanisms, where does that actually leave us?
The honest answer is promising but not proven. This review pulled together a genuinely large body of evidence, in vivo and in vitro studies, across rodents, humans, and cell cultures. And the beneficial effects on insulin resistance and glucose tolerance that showed up in animal and cell studies were, in many cases, echoed in the human studies too.
But not universally.
Not universally. There were plenty of studies with less pronounced effects, or none at all. And notably, most of the human studies that didn't find a positive result were using less sensitive measurement methods, and insulin sensitivity was often only a secondary measurement in those trials rather than the main focus.
So the way a study is designed might matter just as much as what it's actually testing? That's really the core takeaway. The types of berries used, whether it was whole fruit versus extracts, the population being studied, how long the trial ran, all of that varied enormously between studies. And that variation is a big part of why the results don't line up neatly.
What do the researchers say needs to happen next?
more well-designed, randomized, placebo-controlled clinical trials, ones that look at dose response, compare whole blueberries to isolated bioactive compounds, and track effects over a longer period than the 6 to 8 weeks most current studies use. They also want more research into the exact cellular mechanisms involved, since right now those findings are still inconsistent across studies.
So, if someone's watching this hoping for a simple, yes, blueberries fix insulin resistance,
That's not quite where the science is yet. What we can say is there's real, recurring evidence across multiple types of studies that blueberries may improve insulin sensitivity and glucose tolerance, but the number of clinical studies is still limited, and firm conclusions about their anti-diabetic effect can't be drawn just yet.
it's a watch this space story more than a case closed one.
Exactly that. If you found this conversation helpful, make sure to like the video, subscribe, and share it with anyone who might be curious about the science behind their next handful of blueberries. Thanks for watching. We'll see you in the next one.